Right now, tonight, there's a chunk of ice and dust cruising through our solar system that's blown up so fast and so big, it's basically looking like it could swallow a whole planet. Just a few months back, this thing was way too dim for pretty much any backyard telescope to even catch. Today, it's bright enough to spot with a cheap pair of binoculars, and it's still getting bigger. This is the story of Comet 220P McNaught, and what's gone down with it over the last 10 weeks is one of the craziest, most out-of-nowhere comet moments skywatchers have caught in years. Let's start with the basics, because this is a real-deal object with real history, not some internet myth. Comet 220P McNaught was found on May 20th, 2004, by Aussie astronomer Robert McNaught, working out of Siding Spring Observatory. McNaught's kind of a legend in comet circles. Over his career, he bagged dozens of comets, and this one, just called 220P, was nothing but a faint smudge back then, sitting at around magnitude 17. For comparison, the dimmest stars you can catch with the naked eye on a clear night usually sit around magnitude 6. Magnitude 17 is thousands of times fainter than that. You need serious gear and a long exposure to even notice something that faint. 220P McNaught belongs to a squad of comets called Jupiter family comets. These are short-period comets whose orbits have been yanked and shaped by Jupiter's gravity over the long haul. Instead of ghosting out to the edge of the solar system like the big-name long-period comets, Jupiter family comets stick around relatively close in, looping the sun every few years. For 220P, one full lap takes about 5.5 years. Its closest brush with the sun, perihelion, brings it to about 1.6 astronomical units out, just past Mars's orbit. Its farthest point, aphelion, sends it out past Jupiter's general neighborhood before it swings back in. So this comet's whole life is shuttling back and forth across the inner asteroid belt, diving in close and pulling back out. For most of its history, since it was discovered, 220P kept it chill and acted like small comets usually do. It brightens up a bit near the sun, fades as it pulls away, nothing wild. That changed this year. In late May 2026, comet watchers using data from the Zwicky Transient Facility, a robot sky survey scanning the heavens every single night, clocked something off. An astronomer named Mike Kelly flagged it first. The comet had suddenly spiked in brightness by about 7 magnitudes. In plain terms, that's roughly a 600x jump in brightness in a tiny window somewhere between 13 and 14 hours. Other observers tracking it in the days after said it kept climbing, all the way to about magnitude 8.2. That would mean the comet got brighter by something close to 8,000 times compared to where it was sitting just days earlier. Picture a candle in a pitch-black room suddenly turning into a spotlight overnight. That's basically the scale of what went down. This kind of thing is called a cometary outburst, and even though it sounds dramatic, it's a known, well-studied phenomenon. It happens when a comet's nucleus, the solid chunk of ice, rock, and frozen gas at its core, gets a crack or a weak spot in its crust. As the comet gets closer to the sun, sunlight heats up the surface. Buried underneath are pockets of frozen stuff, like carbon dioxide ice or carbon monoxide ice, which turn to gas at way lower temps than water ice does. When one of those pockets gets exposed, whether from thermal cracking, a mini landslide on the nucleus, or even a tiny piece breaking off, the trapped gas rushes out all at once, dragging a cloud of dust with it. That sudden blast is what we see from Earth as a burst of brightness, since sunlight now has a way bigger cloud of fine dust and gas to bounce off, instead of just the small, solid nucleus. Right around the time of this first outburst, pro-astronomers pointed the TRAPPIST North telescope in Morocco at the comet to get a closer look at its chemistry. What they found was pretty interesting. The comet's coma, the cloud of gas and dust wrapped around the nucleus, was packing an unusually high amount of a molecule called diatomic carbon, aka C2, compared to another common cometary gas called cyanogen, or CN. Diatomic carbon is part of why comet comas often glow with that greenish tint, since C2 lights up strongly in that part of the color spectrum when sunlight gets it hyped up. The astronomers also noticed a narrow, intense dust tail that really stood out in their shots, and floated the idea that the outburst might be tied to the nucleus actually cracking apart a little, or what scientists call a fragmentation event. When a comet nucleus loses a piece of itself, big or small, it exposes fresh ice that's never felt sunlight before, and that fresh ice can vaporize violently. The comet hit its perihelion, its closest pass by the sun, on June 14, 2026, at the distance of about 1.6 astronomical units. That timing matters, because comets are most likely to pop off with outbursts when they're closest to the sun and soaking up the most heat. Turns out the comet had already started calming down before it even hit that closest point. By early June, observers noticed its dust output had already dropped noticeably from one night to the next, and over the following weeks it faded steadily. By June 8th, it had dimmed to around magnitude 11. still way brighter than its original state, but clearly chilling out from its explosive peak. Astrophotographers caught it during this fading stretch, showing a coma stretched into a teardrop shape with a spread out, less concentrated center, a sign the burst material was slowly spreading out and thinning into space. By early August, it had faded further, down to around magnitude 13. Then, on August 5th, it happened again. Out of nowhere, the comet brightened a second time, jumping back up to around magnitude 7, arguably even brighter than the peak of its first outburst just 2 months earlier. This second flare-up caught the amateur astronomy crowd off guard all over again. A comet pulling one major surprise outburst in a single apparition is already pretty rare. Pulling off two big outbursts within the same close pass by the Sun, only about 2 months apart, is even rarer, and it's put 220p McNaught front and center on comet watchers' radar around the globe. Everybody's tracking it night after night now to see what it does next. What makes an object like this worth caring about isn't really its size in the usual sense. The solid nucleus of 220p is tiny. Based on studies of similar Jupiter family comets, nuclei like this one are typically only 1 to 2 kilometers across, sometimes even smaller, barely bigger than a small town. You could drive across it in a few minutes if it somehow had roads, but the coma, the cloud that forms once it starts venting gas and dust, is a whole different story. Since there's basically no air resistance in space to hold the cloud together and the pressure released during an outburst shoves material outward in every direction, comas can balloon out to sizes that dwarf entire planets, even though the object making that cloud stays small and solid at its core. This isn't a new idea in comet science, and there's a famous historical example that shows just how nuts this can get. In October 2007, a comet called 17P Holmes had one of the most dramatic outbursts ever recorded. It brightened by roughly 1 million times in a matter of days, jumping from a faint magnitude 17 all the way to about magnitude 2.8. Easy, naked eye bright, even from a city. In the weeks after, the cloud of gas and dust it threw off expanded so much that, at its biggest, the coma of Comet Holmes actually got physically bigger in diameter than the Sun itself, even though the solid nucleus making all that material was only estimated to be a few kilometers wide. It's still one of the most talked about cometary events in modern astronomy, and it's the clearest proof that a small, forgettable chunk of ice can, for a brief window, throw off a cloud of material that's genuinely planet-sized or bigger. 220p. McNaught's outbursts this year are being watched with that history in mind. While detailed measurements of exactly how huge its coma has gotten during this 2nd August flare-up are still being gathered and confirmed as new images roll in, the pattern already fits the profile of a comet going through a legit burst of activity capable of producing a coma many times bigger than the solid body buried inside it. Earlier, during the first outburst back in June, observers already measured a coma stretching several arc minutes across in the sky, plus a faint ion tail reported to stretch more than 2 full degrees, roughly 4 times the apparent width of the full moon as seen from Earth. An ion tail that long, made of charged gas particles streaming away and getting pushed by the solar wind, is itself a sign of just how much material got released. So where's this comet at right now, and can you actually go outside and catch it yourself? As of this week, 220p McNaught is chilling in the constellation Cetus, the whale, best seen in the pre-dawn sky. If you're in the northern hemisphere, timing's a little rough right now since a half-lit moon is rising around the same time as the comet, and its glow can wash out a faint, diffuse object like a comet's coma, which doesn't have the sharp pinpoint brightness of a star. Folks in the southern hemisphere have a somewhat better shot, with roughly a 30-minute window and a moonless sky before dawn takes over, though the comet stays pretty low near the eastern horizon during that stretch, so a clear view down to the horizon helps. For anybody trying to catch it, the advice from experienced comet watchers is simple. Get away from city lights, give your eyes at least 15 to 20 minutes to adjust to the dark, and use binoculars if you've got them. Since a diffuse glowing patch is usually easier to spot with binoculars than with just your eyes, a small telescope gives an even better look, maybe showing some structure in the coma or a hint of the tail. Since outbursts like this are inherently unpredictable and comets can fade as fast as they flare up, the general rule among skywatchers is to try and see it ASAP rather than waiting, since there's no guarantee it'll still be this bright next week, or even in a few days. Worth stepping back and asking why scientists care so much about small, dim comets like this one beyond the hype of a surprise outburst. Comets are often called time capsules from the early solar system, when the sun and planets were forming over 4.5 billion years ago. The outer regions of the swirling disk of gas and dust around the young sun were cold enough for ices to form and stick around. Comets are thought to be leftover building blocks from that era, chunks of primitive material that never got scooped into a planet and have been drifting, mostly frozen and untouched, ever since. Every time a comet like 220P swings in close to the sun and its ices start vaporizing, it releases gas and dust that's basically untouched since the solar system was born. Studying the chemistry of that material, like the boosted diatomic carbon signal picked up by astronomers checking out this comet in June, gives scientists real data on what the raw ingredients of our solar system actually look like. No spacecraft required. Jupiter family comets specifically matter because their more frequent close passes by the sun, compared to long period comets that might not swing back for thousands of years, means scientists get repeated shots at studying the same object and watching how it changes and wears down over time. Some Jupiter family comets eventually run out of accessible ice near the surface after enough close passes and basically go dormant, looking more like a plain rocky asteroid. Others, for reasons nobody's fully figured out yet, keep surprising observers with wild activity even after tons of orbits. Whether 220P McNaught settles down after this pair of outbursts, or whether it's got more surprises left before heading back out toward the far end of its orbit, is something only continued watching will answer. This comet isn't out there solo through the summer sky either. Several other periodic comets have been active in 2026, making for a busier than usual season for comet watchers. Comet 10P, or Tempel 2, another periodic object with an orbital period of about 5.5 years, hit its own perihelion on August 2nd, at a distance of about 1.4 astronomical units from the Sun, putting it in roughly the same neighborhood as 220P around the same time. Comet 88P Howell, which also wraps an orbit in roughly 5.5 years, hit perihelion back in March at a similar distance. Let's talk more about that green glow, because it's one of the most eye-catching parts of what people are photographing right now. When you check out recent shots of 220P McNaught, especially ones taken close to the outbursts, the coma often shows a clear greenish tint. That color isn't a camera glitch or a processing trick. It comes straight from the diatomic carbon, the C2 molecule mentioned earlier, which astronomers found in unusually high amounts in this comet's coma. When sunlight hits C2 molecules floating in the near vacuum of space, they get excited and re-emit light at very specific wavelengths. And those wavelengths land right in the green part of the visible spectrum. That's the same basic reason a lot of bright comets throughout history have been described as having a greenish head, even though the tail usually looks more white or bluish, since the tail is dominated by different gases and by sunlight just bouncing off dust grains, rather than glowing on its own. So when astrophotographers post their shots of 220P showing that vivid green core, they're basically capturing a chemical fingerprint of the comet's makeup, not just a cool color. It's also fair to wonder, given how much this comet has blown up, whether there's any reason to worry about it passing near Earth. Short answer, nope. Comet 220P. McNaught stays out near Mars' orbit during this leg of its journey, more than 1.5 astronomical units from the Sun at its closest, which puts it tens of millions of kilometers from Earth, even at the nearest point in its current orbit. Its path doesn't put it anywhere near a collision course with our planet. Astronomers track periodic comets like this one closely because their orbits, once nailed down through repeated observation, get pretty predictable in terms of where the comet will be years or even decades down the line, even if exactly when it'll have an outburst stays impossible to call. The interesting part here is entirely about brightness and visibility from a huge distance, not proximity or any kind of actual risk. Also worth remembering, Robert McNaught, the guy this comet's named after, has one of the most stacked careers in comet hunting history. Over the course of his work, mostly using wide-field survey telescopes built to sweep huge chunks of sky hunting for moving objects, he racked up dozens of comet discoveries, and this one, found back in 2004, was actually the very first to carry his name in the official catalog. Comets traditionally get named after whoever found them, which is why you'll often see the same last name attached to a bunch of different numbered comets, since one dedicated observer with the right gear can rack up multiple finds over a career. It's a nice bit of context for an object that, more than 20 years after it was first spotted as a barely there smudge, is now putting on the most dramatic show of its observed history. It's also worth putting this event up against comet outbursts that have made headlines in past years, since it helps explain why this particular case has generated so much buzz. Beyond the extreme example of Comet Holmes in 2027, smaller outbursts happen more often than most people realize. Comet 29P Schwarzmann-Wachmann, for instance, is famous among comet watchers for regular outbursts, usually brightening somewhere between 1 and 4 magnitudes at a time, way more modest than what 220P just pulled off twice in a row. What sets 220P McNaught apart this year is both the sheer scale of its first jump, roughly 8,000 times brighter in about half a day, and the fact that it repeated a major flare a second time within the same apparition, something way less common and one astronomers don't fully understand the mechanics of yet. Some comet scientists think that once a nucleus gets one major crack or fracture event, the exposed area from that first outburst can stay unstable, and prone to more collapses or venting as the comet keeps getting heated by the sun, which could help explain repeat outbursts like this. Others point to the possibility of the nucleus actually being more than one loosely bound piece, something astronomers have documented in a handful of other comets, where each piece can vent independently at different times. At this stage, with the second outburst only days old, researchers are still gathering images and spectra trying to figure out exactly what triggered this repeat performance, and it might be a while before a clear answer shows up, if one shows up at all. Comet behavior, even after decades of study, is still genuinely hard to call. There's something worth sitting with here beyond just the numbers. A chunk of ice and rock roughly the size of a small hill, drifting mostly unnoticed for most of its multi-year loop around the sun, went off twice in the span of 2 months, releasing enough material to become, briefly, one of the most talked about objects in the amateur astronomy world. It went from being so faint that only a robot survey camera scanning the whole sky every night would even register it, to something a person standing in a dark backyard with $10 binoculars can actually pick out against the stars. That kind of glow-up, driven purely by heat, ice, and the physics of a cracking surface millions of kilometers away, is part of why comets have grabbed human curiosity for as long as people have been looking up. No need to reach for anything beyond the real physics here. The actual story is dramatic enough on its own. A small, cold, mostly forgotten traveler from the frozen depths of our solar system pulled 2 rounds of activity within the same close pass by the sun, throwing off gas and dust that spread into a glowing cloud big enough to be tracked by observers on every continent. For now, the best move for anyone curious about this event is to just go check it out for themselves if the skies cooperate. Comet 220P. McNaught is sitting low in the pre-dawn sky in the constellation Cetus, catchable with binoculars under a decently dark sky, though moonlight and its low spot near the horizon are making it a bit of a challenge this week, depending on where you're watching from. Whether this second outburst is the last surprise this comet's got for us this year, or whether there's a third act still coming as it keeps its slow retreat away from the sun and back out toward the far reaches of its orbit, nobody can say for sure yet. That unpredictability is exactly what's got comet watchers checking their feeds and telescopes again tonight, and probably again tomorrow night too, just in case this quiet little traveler from the edge of the asteroid belt decides to light up one more time before fading back into the dark for another 5.5 years. If you do manage to spot it, or even just find good pics of it online over the coming days, it's worth taking a sec to think about the scale of what you're actually looking at. A nucleus smaller than most small towns, invisible to the naked eye on its own even with a strong telescope, has thrown off enough gas and dust to build a cloud that from Earth looks like a soft glowing smudge among the stars, bright enough to notice with basic binoculars from a dark backyard. The cloud is made of material that's been locked in deep freeze since before Earth had even fully formed, only now getting its first real taste of sunlight in over 4 billion years. Every time a comet like this flares up, it's giving us a small, temporary window into the earliest chemistry of our solar system, out for a few weeks before it thins out and vanishes back into the emptiness of space. Comet science moves fast when something like this pops off. Observers around the world, from pro observatories running dedicated comet monitoring programs down to amateur astronomers with backyard telescopes and cameras, are all pointing their gear at the same patch of sky right now, comparing notes and posting updated brightness estimates almost daily. That kind of collective, fast-moving observation is exactly how outbursts like what 220P McNaught has pulled off this year get properly documented, tracked, and eventually figured out. So if this is the kind of story that catches your attention, it's worth checking back over the coming days and weeks, because a comet this active, this early in what should have been a quiet apparition, has a real shot at doing something unexpected again before it finally chills out and heads back toward the far, cold edge of its long, looping orbit around the sun